A wrap is another interesting widget. In this example, we have 5 containers with different colors, all with the same size, 80 times 80. There are 2 important elements to consider here. The first one is that I'm using a material app without the usual app bar. This means that when we run the app on modern devices, we might encounter some issues because the GUI could be blocked or displayed incorrectly due to screen cutouts. For example, on iPhones, we have the well-known camera notch. To avoid this problem and ensure that the interface is always displayed properly, we can introduce a special widget called Safe Area. It ensures that the GUI is rendered only within the area considered safe on the screen. In this case, its child is padding, which we have already discussed, and its child in turn is a wrap, where spacing 10 defines the horizontal space between items, and a run spacing 10 defines the vertical space between lines. This means that a wrap allows widgets to automatically move to the next line when there is not enough horizontal space. If we used a simple row, we would likely end up with an overflow and the layout would look terrible. With wrap, however, as you can see in portrait and landscape mode, the horizontal space changes. So in portrait mode, the 5th container moves to a second line, while in landscape mode, all 5 containers can be displayed on the same line. We can of course specify how we want to align or center them. Another widget, called Spacer, is specifically used to manage the space between widgets in a proportional way. For example, if we consider a row with 3 containers, blue, green, and red, each with a fixed width of 50, we can distribute the space between them proportionally using Spacer. In this example, we assign a flex value of 1 to the first spacer and a flex value of 2 to the second one. This means that the available space is divided into 3 parts, 1 plus 2. One part is assigned to the first spacer, and the remaining 2 parts are assigned to the second spacer. This allows flexible control over spacing. The last widget I want to introduce is called Constraint Box. We have already explored Sized Box, which uses a specific predefined size that cannot be adjusted. In contrast with a constraint box, we can define both the minimum and maximum width, as well as the minimum and maximum height. This means that if the content we want to render is bigger than the maximum size, the box cannot grow beyond those limits. At the same time, if the content is very small, the box will still respect the minimum size constraints. In this example, I'm considering the text lorem ipsum dolor sit amet. In the first case, we try to display the whole paragraph, but the constraint box is not large enough to contain it entirely. In the second case, we focus only on the first word, lorem, and even with the minimum sizes set to 50 and 100, the box appears large enough or even too large. Needless to say, all these different widgets can be combined and integrated to produce more complex and sophisticated responsive layouts. Let's now move to the adaptive layout. In this case, we need to change the layout and adapt it for different situations. For example, we may want one layout when the orientation is portrait and another when it's landscape. As already mentioned, we may also want different layouts for different screen sizes. When the screen is large, we can show more content, while when the screen is small, we may need to display less information or present it in a more compact way. To do this, we can use many different widgets. The most specific one is the Orientation Builder. which is specifically designed to handle the two different screen orientations. But we can also use two more general widgets, Layout Builder and Media Query. Layout Builder is useful when we want to react to local changes, meaning that we want the specific context of a widget and work with those constraints. Media Query, on the other hand, is the solution we should adopt when we want global information, since it allows us to consider the characteristics of the entire screen and its overall size. More in detail, we use Media Query when we want to access global information about the device. For example, we want to check whether the device is a phone or a tablet, determine the screen orientation, consider safe areas, or detect whether the keyboard is visible. On the other hand, we use Layout Builder when we want to build a responsive widget within a specific part of the layout. In this case, we adapt to the available space provided by the parent widget. As we said, this is particularly useful when working inside rows, columns, or other layout structures, where the constraints may vary locally. A simple example can help clarify the difference. In both cases, we are using a row with two children. The first child is a red container with a fixed width of 200. The second child is wrapped with expanded. In the first case, inside the expanded widget, we use a layout builder to display the available width. It works locally, so the width it provides corresponds to the maximum width available within that specific context. In this example, the value displayed is 240, which represents the remaining space after the fixed container. In the second case, we use Media Query. We use mediaquery.sizeOfContext.width, which returns the total screen width. As a result, the value displayed is 440, representing the full horizontal size of the screen, not just the remaining space. So the key difference is that Layout Builder provides a local constraint, remaining space, while Media Query provides global information, entire screen size. It's now time we analyze a couple of examples to better understand how the different pieces fit together.